All right, we're back. So we're back to slides. Yay! I knew you guys missed slides. So here's the title slide. The kittens are iterating. Get it? Right? Super appropriate picture. They only get more appropriate as the semester goes. Ding. All right, here we go. So we can skip through a bunch of we've already done the first video and the announcements. All right, so we're just going to start off with the would you rather. All right. Traffic lights probability to be green for you is proportional to how badly you have to go to the bathroom. Meaning, if you don't have to go to the bathroom at all, then traffic lights will act as normal, right? They'll just be normal traffic lights. The chance that you get a green or a red is normal if you don't really have to go to the bathroom. But if you really have to go to the bathroom, it's greens all the way till you get to your destination. Nice. That's just convenient. Or every morning, electronics you own have a new plastic coating. Those like gossamer gentle angel wings. Ooh. Every one of your electronics have a new plastic coating that you can peel off. You just peel it off, and then it just magically evaporates. It doesn't create any waste. You just go, oh, and it just out into the ether, and it's fine. Every morning it's a new one. If it's when it's on there, it doesn't at all impede your use of that device, and it'll be on all of your electronics, all of your monitors, your TV, your phone, or whatever. You'll know it's there, but it won't bother you until you kind of try to reach and go, ah, and then you peel it off and ha ha. So that's the would you rather. So I'm gonna pause. I'm gonna do the usual pause thing. Huh? And we're back. Excellent. It's hard to time those little pause poses, but I like to look as dapper as possible. All right, so then let's get started talking about the standard template library. So, the standard template library is built into C++. It contains templatized functions and classes. So in the last video, we templatized our stack class, but you can also templatize an individual um, function, right? So an example templatized function is sort, which you give a random access iterator for start and end, and it'll work, right? Um, we'll talk about iterators in a little bit so that you can actually learn how sort works, and to use it. But that's just an example of how to call the sort method or function. In case you haven't had this, it's technically you refer to functions that are inside a class as methods and functions that are outside of a class as functions, technically. I guess some people might argue that they're all functions and methods are a special type of function. Whatever. I try to use them correctly, but it doesn't super matter. It's like, you know, ending a sentence with a preposition. It's fine. Some prepositions are particles. They're meant to be that way. But let's stop with the word nerding, and I'm going to clean my glasses while we go over this slide because I can't see. So the main thing that you're going to use the STL for is the classes that live inside of there. And in this class, 341 data structures, we're actually going to learn how all of those classes are implemented. Meaning, after this class, you should be able to pull out a data structure from STL, any of those classes, and know generally what's going on in there and how it's implemented. For instance, the vector in there is a dynamic list that's resize. It's just a resizing array underneath. The list class is a doubly linked list class. Um, and the stack is basically just a more feature-rich, non-terrible version of what we implemented last class, right? Oh, there's still a spot. There's always a spot right where your pupil is on glasses when you're cleaning them. It's like, I don't care if there's one at the bottom corner. Anyway, excellent. So I just want to take a second to talk about sets. Um, that is an abstract data type. Actually, we kind of glossed over this point last time, and I do like to kind of make this distinction. Um, there's uh, we refer to data structures in kind of two ways. We talk about data structures, which is like how we implement a particular storage method. And then we have an abstract data type, which is it's an advertised set of features for a data structure, right? So an abstract data type is, for instance, a stack is an abstract data type over here. And when you define an abstract data type, you're defining what the data structure does and what all of its methods accomplish, right? So when we talk about a stack as an abstract data type, we will say, well, it has a push method that adds one data item to the stack, and then the pop method will remove the most recently pushed item from the stack and return it to you so you can do something with it. So that would be like the abstract data type definition of a stack. So that's, we'll say, the specification. Abstract data type specification. What does it do? So this is something you would be interested in if you were going to use a stack, right? The data structure is the implementation. Specification, implementation. And this is what you care about if you're actually going to write the stack, the code for the stack. So that would be, I thought there was a spider up there. It's cool. There's no spider. I have to befriend. The data structure is how the stack is implemented. And so when we implemented the stack last time, we used a linked list. So we had a node, we had a pointer to the top of the stack, and then the object on the top of the stack had a pointer to the thing under it, had a pointer to the thing under it, and so on and so forth. That would be the data structure consideration. So you can have the abstract data type, which specifies the functionality, and then the data structure that actually implements it. When we're talking about performance considerations, which one do we look at? Which one do we look at? We look at the data structure. And the reason we look at the data structure is because we actually know how it's implemented, and so that we can go look at code or pseudocode to determine the performance of all of these methods. An interesting thing to note is that one abstract data type may have many different ways of being implemented. For instance, we could use a static array underneath, which would mean that the stack has a fixed size. We could use a dynamic array underneath, meaning when it gets full, we just double the size of the array and copy everything over. Or we could use a linked list, right? All of these three different implementations have slightly different performance concerns and kind of impact the abstract data type, right? Because if you say to somebody who's using it, it has a fixed size, then that kind of changes how someone might use your stack, right? But typically, different implementations only affect the performance of the data structure, not really what kinds of features and functionalities the data structure provides. Whew. So, what is a set? It is an abstract data type, meaning this, I'm just going to talk about what it does right now, and we won't talk about how it gets implemented. And you can speculate how to efficiently implement a set. In fact, you could absolutely implement a set now with what you know how to do, and maybe if you're mega clever, you'd figure out the most efficient way of doing it. You can actually do all of its operations in constant time. What? But it stores a group of items with no duplicates. If you add a duplicate to a set, not all of its operations, but most of its operations, if you add a duplicate to a set, it will ignore your addition, right? So it's like a mathematical set. You're saying what things are members of this set. So if I add Jules the cat to the set, yeah, he's like, what? Don't wake me up. I'm sleeping. If I add Jules to the set and then I try to add Jules again, it's like, well, Jules is already in the set. So they're useful if you want to do set type of operations like intersection, union, difference, but they're also useful for if you just want to put a bunch of stuff into a data structure that will automatically disregard duplicates, right? For instance, if you have a bunch of students trying to register for a class. If a student tries to register twice and you're using a set for the data structure, then multiple registrations from the same student will just get ignored automatically because the set will be like, I already have that student, forget about it. All right, so that's a set. We'll be learning an efficient implementation of a set called a hash table later in the semester. Boop. Here's an octopus fact because we need octopus facts in our lives. Why does this slide exist? So that I'm hoping some of you who are flipping through will go, wait, what? Anyway, there's a hair in the air. Octopus is definitely cooler than me. They have octopuses. Their arm brains, so two-thirds of the neurons in their body, all their two-thirds of their brain matter is actually in their arms. So their appendages actually have a mind of their own. There are videos you can go see on YouTube of an octopus arm that has been uh, removed, and they can regrow their arms too, because of course they can. They're awesome. If the arm that has been cut off from the octopus will continue to hunt for food and try to bring it back to a mouth that is no longer present. Meaning, the detached arm will just kind of float around and be like, crab! And grab a crab and try to like pull it back to the mouth that is no longer there. I mean, just take a moment and think about what it would be like to be an animal that actually has like its appendages actually have a mind of their own. Uh Also the suckers on an octopus are effectively like tongues in a sense that they can taste what they touch. There's a really cool article about it's basically an essay from an octopus researcher just talking about how cool they are, and they would reach out of their tanks to like touch the researchers because it would give them a better sense of like how to identify individual human researchers, which I thought was super cool. There's another story in there where one of the octopuses just didn't like one of the researchers. It's like, nah, 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 no, we're not gonna be friends. I'm just gonna say that now. Didn't like this guy so much that when he was in the lab, they were like open topped when they were researching them. If that guy walked by, the octopus would squirt water out of the tank and get him wet. That sucks. They have three hearts, one for their organs and two for their gills. So to pump all that blood around. When they do the water squirting and the jetting around, the organ heart that gives blood to their organs stops beating. They give themselves a heart attack to jet through the water, which means this one octopus hated that guy so much that it willingly gave itself a little mini heart attack just to get him wet and see him be mad. um, as you can tell from all this behavior, they're actually very smart. Unfortunately, due to their short lifespan, we don't quite know what they're capable of over a long period of time, but they can solve puzzles. If they're given a puzzle that they solve, it will take them X amount of time to solve it, and if they're given it like weeks or months later, they will just immediately solve the puzzle. So they not only are smart enough to reason and I believe use tools, they will they will they'll actually do it like they'll remember solutions and leverage them later. They're very smart. Um, in fact, the octopus tank at the Baltimore Aquarium is the only non-mammal tank, I believe, that has toys in it. If you go see the octopus exhibit there, there'll be these little like rubber balls and things in the tank, which you might initially be like, why are those in there? Until you remember they get bored because they're really smart. Um, just a word nerd moment. People will typically correct octopuses to octopi, but actually the word octopus is Greek in origin, meaning you are applying a Latin declension to a Greek word. The Greek declension for the plural of octopus would be octopodes. Now, if you don't want to make any friends, you can start correcting people who say octopi to be like, well, actually, it's octopodes. Or we can just agree that, hey, we're in English, why don't we say octopuses? Because that's fine. In English, we have our own rules for pluralization. We can use those. We can use other languages, that's fine, but, it's an English word at this point as well. So, yeah. If some other language adopted an English word and started to use their grammar rules on it, I'd be like, yeah, that's fine, because you're speaking Japanese or Turkish or whatever language it is. Anyway, that's it for this video. We're gonna resume this video we're gonna start a whole new one and talk about iterators and write a quick iterator. Maybe we'll just talk about them because your homework exercise is the right one. So I don't want to just give you the answer, do I? I don't know. See you in the next one. Bye.